I'm going to provide a quick demonstration of Immuta's R and Scala controls in Databricks. So the first thing I'm going to do is build a policy on this credit card transactions table, which we've exposed as a delta table. One thing that Immuta is able to do is we're able to discover sensitive data in tables. So you can see we discovered person name exists for this customer last name column. So with that, armed with that information, I can go ahead and create what's called a masking policy. So I'm going to say mask names, and we're going to mask columns tagged person name. And there's several different masking types we could do here. I'm going to replace with a constant redacted. And we're going to just do this for everyone. I could add exceptions to this rule though. And we're going to apply this anywhere we see this person name tag. So that happens to be 9 out of 27 of my data sources in Immuta. Some of these could be in Databricks. They could be in other data warehouses as well. It doesn't matter. We can apply this policy consistently no matter where the data lives. So I'm going to go ahead and activate this. It's now turned on, and I'm going to go ahead and pull up a Databricks notebook now. So we've got this Scala notebook, and you can see here the first, or the second cell, I should say, is trying to read some data directly from S3. If you remember, we put a column level policy on this table. So because of that, we are not going to allow people to read directly from S3. Because if they could do that, essentially they would be able to bypass this policy. The policy actually gets enforced as part of a SQL rewrite. So we leverage the compute within Databricks to enforce the policy. So instead, if I construct my data frame in Scala using the initial read from the table rather than directly from S3, that actually will give me the fine-grained control, the column level control that I want. So this is executing that command. You can see that customer last name is redacted from the as we defined with the policy. I also cannot do bad things like drop this table. So if I go ahead and run this cell, we're going to block that operation. So just by building that simple policy in Immuta, you get all this granularity in your Scala notebook. Similarly, we can do the same in R. So if I go ahead and run this cell, I'm again reading through SQL rather than going directly to S3, which we of course would block in this scenario as well. You can see customer last name is redacted. And if I try to drop the table here, we get the same block attempt from doing that. So one last thing I want to show is that we worked on this Scala standard security testing notebook in conjunction with Databricks. So essentially, because of the lack of process isolation and you're running as root with Scala, there's a lot of bad things that someone can do on a cluster. So we've got a ton of stuff in here. I was just going to show this one where you could actually attempt to steal another user's token. So if I go ahead and run this cell, this will provide a great example of how we block the users from certain trusted classes on the cluster. So I'm not able to do this kind of attack on an Immuta-enabled cluster. And just to give you a sense of what an Immuta-enabled cluster means, never mind, I'm not going to show you that. So I go to the clusters. We actually have a Spark config that we have in the cluster, which essentially enables or makes the cluster Immuta aware so that all these controls now get enforced. So that's pretty much it. Please reach out if you have some questions. We also have a free trial that you could spin up yourself, hook up to your Databricks cluster, and test this out all on your own without involving us at all. So again, thanks for your time.